In this video tutorial, I'm going to take a look at 8 examples of questions in a topic of algebra and linear relation or linear equations. And this video is the third in this series. I plan to make the other two as well to support preparing for the grade 9 EQAO math test in the province of Ontario. So I went through the last several years' tests, and I pulled out a number of examples. There's 8 in this video relating to algebra, algebraic expressions, simplifying them, and also solving linear equations. And there's actually a number sense enumeration strand in the grade 9 course, but I broke it down into this algebra and linear equations part, and then also a ratio and proportion percent part as well. That's another video. So first of all, we're going to start with the power of a fraction. So for example, if we had 4/3 squared, to evaluate this, both the numerator and denominator both get squared in this case. So we would write 4 squared over 3 squared, and I would evaluate 4 squared is 16, 3 squared or 3 times 3 is 9, so that would equal 16 over 9 or 16 ninths. Now, a slightly different way to ask a similar kind of question is to say, well, x is some fraction like 3/5. Find the value of x to the 4th. So I'm going to start with the x to the 4th here, and we're going to substitute 3/5 in place of x. So it'd be 3/5 to the 4th. So it's a very similar question to this. Now, so then we would have 3 to the 4th in the numerator, 5 to the 4th in the denominator. And so if I evaluate 3 to the 4th, it's 81. If I evaluate 5 to the 4th for the denominator, it's 625. So it will be 81 over 625. I did show this line here. If you happen to have a one of the Texas Instruments graphing calculators, there is a way to evaluate this in one fell swoop. If you type in 3/5 in brackets to the power of 4, which is what this is, and then tell it to put the answer in a fraction, you will get 81 over 625. Example number 2, we're asked to find the value of 3x to the 4th, y to the 5th, if x is 2 and y is -1. So I'm going to start with that expression here and put 2 in place of x here and -1 in place of y here. Now, if you remember order of operations, we have to evaluate powers, exponents, first. So we need to do the 2 to the 4th and the -1 to the 5th before we can do any multiplying, because these three things are multiplied together. These three things are multiplied, but we need to evaluate this and this first. So 2 to the 4th means 2 times 2 times 2 times 2, 4 of them multiplied, which is 16. And -1 to the 5th would be -1 times -1 times -1 times -1 times another -1, 5 of them multiplied, which is -1. Remember, any odd power of -1 is always going to be -1. So we multiply 3 by 16 by -1, we get -48. So that's the value of this 3x squared y to the 5th. Now, there are some questions on the EQAO math test that you need to know exponent laws for. So here's a little review of the 3 main exponent laws. If you're multiplying 2 powers with the same base, to rewrite this as one single power of w in this case, then you add the exponents. Remember, and if you forget which is which here, remember this means that there are a of these w's and there are b of these w's, so there should be a plus b of them altogether. Because remember, the exponents are actually just a count of how many of each one there are. So just as a little aside here, so for example, if you had w squared and you're multiplying it by w cubed, then that would be w to the 5th, because remember, this really means that there are 2 w's here and 3 w's here, so there should be 5 of them altogether. Similar idea for division, w to the a divided by w to the b. Now, dividing, some of these, or these ones divide out with these ones. So you subtract the exponents. So here's another example. So let's say we had w to the 7th divided by w to the 4th, for example. So the w to the 7th means there are 7 w's. So I would have, I'm not going to put the multiplication symbols because I'm kind of out of room here. 4, 5, 6, 7 w's multiplied, divided by, and w to the 4th means there are 4 of them. So, and another one. So it's 4 of them. So like These divide out, these divide, so each W divided by W is 1. So that's why they divide out. Those divide out, those divide out. So notice that there are 3 of them left. W times W times W. So that's why that would be W to the power of 3. Again, the 3 comes from subtracting 7 minus 4. Let's get rid of that. W to the A to the power of B. This is often called the power of a power law. And in that case, you simplify by multiplying the exponents. So one more example here. So let's say we had W squared, and then we're going to cube that. So that would equal W to the 6th. Again, you can actually use this idea up here in order to get that, because this 3 here means there are 3 of the W squareds. So this really is the same as a W squared times a W squared times another W squared. There are 3 of them. And so we see 2 plus 2 plus 2 gives you the 6. Okay, so that's why that's an example of why you multiply them. Okay, so in example 3 here, when you use some of those the exponent laws to find some missing values. So in this one here, we don't know the exponent on the power of x here. So this x to the 8th over x to the 5th, you see that part we can simplify. When we're dividing, we subtract the exponents. So 8 minus 5 is 3, so that part right there simplifies to x to the power of 3. So if we divide these out, so that part's going to be x to the 3rd times this unknown power of x equals x to the 7th. You see, we're multiplying 2 powers at the same base here, so we would add the exponents. 3 plus this number gives you 7, so that has to be a 4, because 4 is what you add to 3 to get 7. So the unknown value would have to be a 4. For b here, this is the power of a power rule. You see the 2 gets multiplied by the unknown number to give you 10. So 2 times some value is 10, so that number would have to be 5. So 2 squared raised to the power of 5 would give you m to the 10th. I said 2, I think. M squared raised to the power of 5 would give you m to the 10th. Last one here. Now, these are monomials, not just simply powers. So negative 4x to the 5th times some unknown value gives you negative 32x to the 7th. So you kind of do it in 2 parts. You look at the coefficients in front. This negative 4 times some number would give you negative 32. So really ask yourself, what do you multiply negative 4 by to give you negative 32? And it would be 8. So the coefficient part is 8. And then what power of x do we multiply by x to the 5th to give you x to the 7th? Well, we're multiplying, so you add the exponents, that first rule up here. So this would have to be x to the power of 2, because 5 and 2 add to that 7. So the unknown monomial here would have to be 8x squared. Example number 4. Simplify expressions. So we're going to take a look at a couple of those here. Now, so to simplify this is called the distributive law. This negative 2 is said to distribute into the brackets. It gets multiplied by all the terms. So negative 2 times 11x would be negative 22x. And then the negative 2 gets multiplied by the negative 7 as well. That's the part that if you haven't done too much of this, that's the part that some people forget. They remember to multiply the coefficient or term in front by the first part, but not the second. It has to be multiplied by everything in brackets. Now this bracket here tells you to stop multiplying by negative 2. Now there's a minus sign here, and it's really like, if you don't see a number, it's like there's a negative 1 here. So that negative 1 is going to get distributed into the brackets. And so negative 1 times 9 is negative 9. And negative 1 times 3x is minus 3x. And then that's the expand part. Now we want to simplify. We want to collect like terms. So negative 22x minus 3x would be negative 25x. And 14 minus 9 would be 5. So negative 25x plus 5 is what that would simplify to. Second one here. So we would distribute the negative 4w into the bracket. So I'm going to multiply negative 4w by w. So that'll give me 4w squared. Remember, we multiply a w by a w, so that one of those exponent laws, those are both 1, so 1 and 1 add to 2, that's why it's a 2 there. And then we multiply the 4w by the -1, so that's going to be a minus 4w. And then this bracket means to stop multiplying by -4w. And now we multiply the -3w into the second set of brackets. So -3w times 2w would be -6w squared. And then -3w times the -5 would be a plus 15w. Negative times the negative is positive, that's why it's a plus 15w. So collecting like terms, 4w squared minus 6w squared would be -2w squared, and -4w and 15w is going to be 11w. They're opposite signs. Remember your integer rules. 15 minus 4 is 11, so that's another reason why it's 11w. Fifth example has to do with some solving. First part really with the equations. Some solving to put equations in y equals mx plus b form. So we're going to rearrange or isolate for y here. So we're going to get the y term alone. So the first thing I would do is take this 3x and also the 20 over to the other side. I want the y term by itself on one side and everything else on the other. And when you take them over, they change their signs. So the -5y stays on the left, and this would be -3x on the right, and the 20 would be a -20 over there. Now I want to isolate for y, so I need to get rid of this -5. So I would divide both sides by -5 so that those divide out. So now I have y alone, and so y would equal 3/5 x. Now negative divided by negative is a positive, so that's why I don't leave the negatives there. So that would simplify to 3/5 x, and -20 divided by -5 is positive 4. Now, before we get into b, a slightly different way you can do this, if you want to, okay, is instead of, I'm going to write out the same equation to begin with, instead of taking the 3x and the 20 over, you could take the -5 over. And then, you see, it's going to be a positive 5y on the right. And then, so I've got the y term by itself, and then in this case, you would just divide out the 5, so that those 5's divide out. And so y is 3/5 x plus 4. So that's the same thing. It's just written in a different order. Y still equals 3/5 x plus 4, same as this. For b here, the next one, again, I want to isolate for the y term. So get the 7y alone. So take the 14x and the -8 both to the right side. And of course, they change signs. So the 14x is positive here, it'd be negative there. The 8 was negative here, it'd be positive over on the right. And then divide out the 7. So -14 divided by 7 is -2. 8 doesn't divide evenly by 7, so we would just leave it as 8/7. So that's what y equals. That's in y equals mx plus b form. Example number 6. So here's 3 examples of solving linear equations. And so for the first one, I want to isolate for x. So kind of similar to solving for y in the last page, I want to get the term that has the x in it alone first. So the first thing I would do is bring this 5 over to the right side. So 5 plus 5 on the left, same as subtracting 5 on the right. So it could be subtracted from the 17, which is 12. And I want to isolate for x, so we'll divide out the 3. So we divide out the 3, 3's divide out, and 12 divided by 3 is 4. So 4 is the solution. Remember, you can always check any solutions by putting that 4, see, back in here in place of x. And you see, 3 times 4 is 12, so that's 12 plus this 5 does equal 17. See, 4 is the solution because it's the number that makes that statement true. Like if I made an error here, get rid of, if I made an error here, and let's say I thought the answer was, oh, I don't know, let's say I made a mistake and I thought the answer was 7. See, if we do 3 times 7, that's supposed to be a 7, plus 5, it's not 17. Because 3 times 7 would be 21, plus 5 would be 26. So it's not working out to equal what this is, so that would tell me that 7 is not the right answer. Second one, b here. So the slightly different thing about b here is that we have a fractional coefficient of the x here. So if you have a fraction, what we're going to do is we're going to get rid of the fraction. And so one thing you learned in the grade 9 math course is that the denominator here is 4. So now there's a single denominator, then you just multiply by that denominator. So I'm going to multiply everything by 4. The 3/4 x, the -2, and the 5. There's 3 things, so all 3 get multiplied by 4. Now, what you do here, the reason for multiplying by 4 is so that this 4 and this 4 divide out. So you see, this part here is just 3 times x, which of course is 3x. Now, -2 times 4 is -8, so that's why there's a -8 here. And 5 times 4 is 20, so that's why there's a 20 there. So I want to, now it's very similar to a. I want to isolate the x term, so get rid of the -8, so bring it over to the right. So be 3x is 20 plus 8, which is 28. And then we divide out the 3. So these 3's divide out, so x would be, and 3 doesn't go into 28 evenly, so we would just write x as 28/3. For c here, 2 ways to solve this. I'm going to show you 2 ways here. So the -3, we could distribute the -3 into the brackets. So I could multiply the -3 in here like this. And so -3 times 4 is -12, sorry, -3 times 4x is -12x. And -3 times the -5 is plus 15. Equals -33. Remember, that bracket tells you to stop multiplying by -3. You do not multiply the -3 by the -33 over here. That's just -33. So now I want to isolate the term that has x in it, so the -12x term, so I want to get rid of the 15, so we're going to bring it over here and subtract it from the -33. See, it's a plus 15 there. So the -33 goes over here, we're going to subtract 15 from it. -33 minus 15 is -48. It's really like adding -33 and -15. See, 33 and 15 add to 48, so it would be -48. And then we divide it to -12. So these -12's divide out, and so we get 4. -48 divided by -12 is positive 4. Now I said I was going to show you 2 ways to do this. So another way, so let's start with exactly the same question, is, and if this works out nicely, this is another strategy you can use. See, notice that this number divides evenly into that number. Okay, so if this -3 didn't go into what's over here evenly, I wouldn't bother try to do this. It would still work, but you would get into fractions and it might make things more complicated. But if that divides into this evenly, what you can do first is divide out the -3. So you see, my whole purpose for doing this, because that divides out, so on the left I now just have the 4x minus 5. And so, and -33 divided by -3 is 11. So I divide -3, I get this, bring the 5 over and add it to the 11, which is 16, and then divide it to 4. I guess, of course, we get 4 again. We have to get the same answer. So that's another way you can do that. I wouldn't bother if that number didn't go into this number. I'd probably just use this strategy over here. Okay, last page here, a couple examples in this one. Solving linear equations using the slope formula. So in this first example, number 7 here, we're told that the endpoints of line segment CD are 4, -6, and -3k. So we don't know what k is, and we're asked to find it. We're asked to find the value of k if the slope of this line segment is -2. So here's the slope formula, and in these kinds of questions on the EQAO test, you're often given what the formula is. So, so in the formula, now, in case you forget, the subscripts here in the formula are just referring to this is the first point, this is the second point, or the other way around. So I'm going to call this the first point. So this is my x1, this is my y1, this is my x2, this is my y2. So I'm going to substitute all these into the slope formula. So see, on the top it's y2 minus y1, so it would be the k minus the -6. That's what's here. And see, x2 minus x1 in the bottom, in the denominator. So that would be -3 minus the 4. negative 3 minus 4. And see, the slope is negative 2. We're told that, so negative 2 goes in place of m here. Now, I'm going to simplify this first before we start solving for k. So k subtract negative 6 is the same as k plus 6. And negative 3 minus 4 is negative 7. So now I have a fraction, kind of like one of the examples in the previous page. So in order to get rid of this negative 7, this denominator negative 7, I'm going to multiply both sides by negative 7. And the whole purpose of that is so that this divides it with this. So now I don't have a fraction anymore. On the right side, I just have this k plus 6. And of course, on the left, negative 7 times negative 2 is 14. And k plus 6 on the right. So now I want to isolate for k, so get the 6 over here and subtract it from the 14, and k will be 8. So that would be your k value. So this is the point negative 3 comma 8. So last example, solving linear equations using the equation of a line. So in this question, you're told that Joe charges $40 as a service fee to travel to a house, and then he charges $25 per hour to fix plumbing problems. And we're told that Mary has $210 in her purse, so she must have a plumbing problem, so she calls Joe to come fix her plumbing problem, whatever it is. And we're asked how long a repair, so how many hours, does she have enough money to pay Joe, okay, without going and getting more cash from the Instabank or something like that. Now, this is a partial variation because there's a fixed fee and also a fee per hour. So if I call C the cost, the total cost, and N the number of hours, then Joe's cost formula is it's 25 times the number of hours plus the $40. So she's got $210 in her purse. So we're going to put 210 in place of C and solve to find N. We want to find the number of hours that she is able to pay for. So the first thing I would do, I want to get the N term alone, so I get rid of the 40. So we'll bring the 40 over here and subtract from the 210. So 210 minus 40 would equal to 25N. And that subtracts to 170. And so I want to isolate for N, so I need to get rid of the 25. So we're going to divide both sides by 25. And 170 divided by 25 is 6.8. Now, Mary only has $200. You would not round this to 7. This is one of the few times when you actually would round down. See, she's only able to pay for a 6-hour repair. If we rounded this to 7 and put 7 in place of N here, we would go 25 times 7 plus 40. See, that's 175 plus 40. If he actually worked 7 hours, she would need $215, but she only has 210. So you would actually not round that to 7. You would round down to 6. She's got a little more than enough to pay for 6 hours, but she's $5 short of having enough to pay for 7. So you would say she has enough for a 6-hour repair. And that's the last example in this video. So there are 2 other videos I've made already. I hope to get the other 2 done, 2 other videos besides this one. There's 2 more I want to do. There will be resource documents. I made up a number of sample questions with each of these, and also a document that has worked solutions as well. I hope eventually to have videos that go over all the worked solutions, but I don't have them done yet. So in the links, the description, sorry, you'll see a link for the practice questions and also solutions for these as well.